Good morning, students. Sorry, good afternoon, students. In the tomorrow's class, the technical issue, some of the nomenclature video is not uploaded still, so I'll continue with that. The nomenclature of haloalkanes and haloarenes. So in that, the first one is structure. Next, common name and IUPAC name. Okay, that IUPAC means International Union for Pure and Applied Chemistry. Okay, so here the structure will start with this methane. Okay, CH4. Here, what is this haloalkanes and haloarenes means the one hydrogen atom is replaced by any halogen atom. CH3Cl. So in the common name they called as what? Alkyl halides. In the place of alkyl here it is methyl is there. Okay. In the place of halide, chloride is there. So students, as I told you before, here last is always replaced by the respective functional group. So in the naming, no need to write here the E is here because last is replaced by chloride. That is methyl chloride. So in the IUPAC name they named as haloalkanes. Halo means in the place of halo, chloro is there. So that is chloro. In the place of alkane, one carbon atom is there. That is chloromethane. Okay. So next one structure. CH3, CH2, Br. CH3, CH2, Br. Okay. So here two carbon atoms are there. Then the parent chain is eth. Ethyl, methyl, ethane. Okay, two carbon atom means prefix is what? Eth. So here, in the place of methyl, alkyl, it takes ethyl. In the place of halide, bromide is there. That means bromide. That is ethyl bromide. Okay. So in IUPAC name, we want to write means the place of aloe, bromo is there. That is bromomethane. Okay. Next. So students, this is alkyl halide. This is a primary alkyl halide because the halogen to which the carbon attached is further attached to one carbon. Here, the halogen which is attached to the carbon, that is further attached to two carbons, then it is a secondary. So in the common name, the secondary gets the prefix iso. Okay, and the another one thing is in this common name, we have to consider all the carbon atoms which are present in the parent chain. Whether the parent chain or in the substituent, we are going to consider all the carbon atoms. So here 1, 2, 3 are there. That means propyl, isopropyl chloride. Okay. So another thing we have to remember, students. So while naming the IUPAC name, the parent chain is very, very important. Parent chain is very, very important. Then will this become what? 2-chloro propane. 2-chloro-propane. So in the name, if you consider this one, CH3, CH3, CH3. Okay. So here, for the halogen which is attached to the one carbon that is further attached to 3 carbons. That means this is tertiary. The total number of carbon atom here is 1, 2, 3, 4. Then it is butyl. Here halogen present here is what? Chloride. tertiary butyl chloride. Okay, so if we want to write the impact name, then we have to consider the carbon atom with the maximum parent chain with the maximum number of carbon atom. This is what it is. At the second position, methyl is there, chloro is there. According to alphabetical order, C comes first. Okay, so that means 2-chloro. Okay, again hyphen 2-methyl. 2-chloro, 2-methyl, and that one is propane. Okay. Next. Here I write. Okay. So here, students, the carbon which is attached to this, halogen which is attached to one carbon, which is further attached to one carbon only. This is primary. But if one carbon which is attached to further 4 carbons, that is named as neo. Okay. So neo, and the number of carbon atoms here is 1, 2, 3, 4, 5. So that means pentyl. Okay. This one is neo pentyl bromide. Okay. If we want to write it in the IUPAC name, so listen, this is also the consists of a parent chain with the 3 carbon atom. This is also a parent chain with the 3 carbon atom. But along with the parent chain here, Br is also there. So we are considering this one as a parent chain. So numbering start from here 1, 2, 3. Because difference is given to the parent chain as well as the halogen atom. Okay, that means what? This become 2, 2 dimethyl. 2, 2 dimethyl, and this one is 1. Sorry. Instead of methyl, bromo will come first. Okay, that is 1 bromo, 2, 2 dimethyl propane. This is the name. So students, in the common name, here the 3 carbon atom propane is there, here it is butyl, here it is pentyl. But in the IUPAC name, the parent chain is propane only remaining as a substituent. Okay, that is the difference between the IUPAC name and the common name. So in the examination, they always used to ask IUPAC name. Okay, this is the nomenclature of alkyl acids, monoalkyl acids, especially haloalkanes. We may write it for haloalkenes also, haloalkynes also. Okay, I'll go with haloalkenes. Next, that is CH2 double bond CH CH2 Cl. Are you assuming? I. Not only Cl here, you may take as I also. Okay, sir. So here, the halogen atom which is attached to the carbon, this is sp3 hybridized. Okay, which is further attached to sp2 hybridized carbon atom. That means if the halogen atom which is attached to sp3 hybridized, which is directly attached to sp2 hybridized carbon atom, then the common name for us what? Allylic. The common name is allylic. Okay, this type of sp3 hybridized attached to the halogen attached to sp2 hybridized carbon. Then that is allylic. Here 1, 2, 3 carbon atoms are there. Then it is propylic iodide. Propylic iodide. Okay. So in the IUPAC name we have to consider preference always given to a double bond. So the numbering should be done from here 1, 2, 3. Okay. That means 3 iodo pro E at which position? First position. Okay, this is iodopropene. At third position iodo, first position E. So 3 iodo pro 1 E. Understand? So next one is CH3, CH double bond CH, CH2 Br. Okay. Here also same thing. The halogen attached to carbon, which is attached to the sp2 hybridized carbon. So the name follows. Allylic means here 4 carbon atoms are there. This is butylic bromide. So in this IUPAC common name, students, we didn't find any where the double bond is exactly present. The name follows propylic only. It is butylic only. We don't know the double bond may be present here, may be present here, may be present here. Understand? So from this we cannot easily say it as where the actually the double bond present. We can just simplify that the halogen to which it is attached, which is further bonded to a sp3 hybridized, sorry, sp2 hybridized carbon atom. Listen, it may be like this also. Here it is a double bond. Okay, this is CH3. Or if it is attached to Br, this is also a butylic. Correct? So the halogen which is attached to the carbon, which is attached to sp2 hybridized carbon, this is also a butylic. Understand? So that means what I am telling is, in the common name we cannot exactly say the position of the double bond. So the common names are not that much accurate as the IUPAC names. So that's why in the entire world, everyone follows the IUPAC name. Okay, next. So this one is at position 1, 2, 3, 4. From here also it takes same 1, 2, 3, 4. From here it is 1, 2, 3, 4. Okay, if you consider lowest symbol, here double bond is at the second position, bromide is at the fourth position, the sum is 6. Here the bromide is at the first position, double bond is just the second position, the sum is 3. So which one is the correct order? Right to left is the correct order of numbering the compound. Okay, so then what happens here? It forms 1 bromo but 2 E. Okay, 1 bromo but 2 E. This is the name of the compound. Okay, students. So the next one is CH2 double bond CH Cl. So if this type of compound is there, it is simply a vinyl fluoride. So this is simply a vinyl fluoride. Okay, but in IUPAC name, this is 1, this is 2. Okay, that must be 1 chloro in 1 E. I will say chloroethene because chloroethene remains same as we write from this side or this side. You may write simply as chloroethene. So students, if 2 or more substituents are there, then only need of writing 1, 2, 3 position is there. If nothing is there, only 2 carbon atoms are there, then no need to write the position 1. So it is simply chloroethene as also correct. 1 chloroeth 1 is also correct. But this is the exact way of writing the IUPAC nomenclature. Okay. Next, instead of the repeated CH3, CH, double bond, CH, Br. Okay. So at the first position, Br is also there. First position, propane is also there. You can say it as bromopropane, one bromopropane. Okay. And instead of that, you may write it as one bromo, pro, one ene. In the right position, or you simply write one bromopropane, that is also correct. Understand? So this is all about the nomenclature of haloalkanes. Now we will discuss the nomenclature of haloarenes. Means in the benzene ring compounds. What happens? So students, instead of one or two compounds, so one halogen, two or more halogens are there. That means it follows the name dichloride, dichloro, like that with the position. So I will give one example for that also. Listen, CHCl3 is there. That's it. Okay. The CH3Cl means this is a methyl group. This is methyl trichloride. Okay. IUPAC name follows what? Haloalkane. How many halogen groups are there? 3. That means tri. Chloro, methane. Here there is no need to write the position because only one carbon atom is there. Okay. Next consider. CH3 single bond CHCl2. If the halogen which is attached to the same carbon atom, then it is said to be what? Geminal. These are geminal dihalides. That is the common. But here you have to write means this is ethyl dichloride. Two carbon atoms are there, ethyl dichloride. Okay. In the IUPAC name you can easily write. Listen, this is 1, this is 2. Correct? Then you may write here 1, 1 dichloro ethane. Okay, students. Now listen. If you consider this one as CH2Cl, CH2Cl, this is also ethyl dichloride. This is written as ethylene dichloride actually. Okay, ethylene dichloride. But simple name I am telling. This is also ethyl dichloride. This is also ethyl dichloride. We cannot distinguish between whether it is geminal or vicinal. But in the IUPAC name we can. So this is 1. This is 1, 2 means this is 1, 2 dichloro ethane. So in the IUPAC name we can easily consider that here the same carbon atom halogens are attached, here to the different carbon atom halogens are attached. Okay, so this is if 2 or more compounds are there. If based on the number of halogen atoms they classified or they guess the prefix mono, di, tri, etc. Okay, so this is all about the nomenclature of haloalkanes. So we will go with the haloarenes. So in the haloarene students, number of ways are there to name the compounds because organic compounds are named itself with the different commercial names and also common names. I will explain, then you will understand. Listen. If benzene ring is there, to that benzene ring, one Br is attached. Okay, then it is benzyl bromide. Like alkyl halide, this is benzyl bromide. Okay, so better I'll say Only IUPAC name here. Okay, I'll explain only IUPAC name. Common name is only for this benzyl bromide, benzyl iodide. Remaining that we cannot justify the common name for these organic compounds. So this is bromobenzene. Initially, we didn't mention any functional groups here or any number here. Okay, this is simply a bromobenzene. So you consider this. Okay, Br is here. With respect to the students, these two are ortho positions. Correct? This one, this are ortho position. This one is para position. Correct? And these two are what? Meta position. So in the benzene ring, ortho, meta, para positions are there. Two are ortho, two are meta, one is para. Okay, with respect to the functional group. If it is here, these two are para, these two are meta, this one is ortho. With respect to the functional group, I am telling. Okay, so consider next example. Here it is here. Okay. Now, in the common name, if you want to write, this becomes with respect to this Br, which position it is? This is the Br. Adjacent to that is ortho position. With respect to here, adjacent. So with respect to this, adjacent. That is ortho. Next to adjacent, para. Opposite, meta. Sorry, this one is meta, opposite is para. Okay. So listen. Here this is ortho dibromobenzene. Understand? Ortho dibromobenzene. This is IUPAC. If you consider the common name, this ortho position, this is the carbon atom, this is alpha carbon atom, beta carbon atom, gamma carbon atom. Okay? Alpha dibromobenzene means that is the name of this compound. So these two are ortho position with respect to each other. So instead of that, if you consider Br here, so Br with respect to which position? Meta position. So then this is meta dibromobenzene. Here with respect to meta means then meta dibromobenzene. So if you consider Br here, then it is para dibromobenzene. So students, this is with respect to what? The position of the functional group in which they are attached to the double bond. So here it is Br the meta position, right? Here also here also here. Okay, so that is opposite means that is meta position. Para position, para dibromobenzene. So these are depends on if only one bromide atom is there, that is bromobenzene. If two atoms are there with respect to ortho position, ortho dibromobenzene. Next this is meta dibromo. This one is para. Okay. So if you want to name this one, you may also write here. So this is first carbon atom, second, third, fourth, fifth, sixth. You can write the position names. This is 1,3 dibromobenzene. Here it is 1,2, not 3. 1,2 dibromobenzene. Correct? Next, here. This is 1, 2, 3. Then it is 1,3 dibromobenzene. This is what? With respect to number, position. Here this is 1, 2, 3, 4 means 1,4 dibromobenzene. Understand? So this is the way to write the name of the compounds. Okay. If along with this halogen, any other functional groups are there. Okay. So I will explain. Okay. So here, along with this halogens, any functional groups are there. Listen, this one. Like OH and Br. Br. Instead of Br, you may take Cl also. Okay. So students here remember, so among alcohols and these halogens, if we see the reactivity order, the preference is given to these alcohols, not to these halogen compounds. Always, I'll write first. You know the carboxylic acid group, COOH, it gets the most priority. If in the compound, carboxylic acid group is there, halogen is there, amine is there, everything is there, then the priority is given to this. Next, I'll write the order of priority. Next, COOR. This is carboxylic acid. This one is ester. Next priority is CONH2. That is amide. Okay. Next priority is C double bond OH. That is aldehyde. Next priority is C double bond O. That means ketone. Next one is for NH2, amine. Next one is OH. Next one is ether. Next, the multiple bonds, double and triple bond. Last halogen. Means X. This is the order of priority. So if double bond is there, halogen is there, preference is given to double bond. If ether is there, halogen is there, preference is given to ether. If ether is there, alcohol is there, preference is given to alcohol. Like that. This is the order of priority. You have to remember this. If you want to mug up, you can mug up also, but you have to remember this. The order of priority. Here, halogen is also there, OH is also there. According to priority order, priority is given to what? OH group. That means here this complete is called as what? Phenol. Okay, students. With respect to this OH group, this is the position 1, 2, 3, 4. Okay, you can write it as 4-chlorophenol. Okay, write it as what? 4-chlorophenol. Or you can remember, with respect to this OH, these two are ortho position, these two are meta, this one is para. So you may also write it as para-chlorophenol. So in the nomenclature, it cannot be said as 1-OL 4-chloro like that. Okay, it cannot be written as 4-chlorobenzenol, 4-chlorophenol like that. Understand? You may write it as 4-chlorobenzenol also. Benzene, the last is replaced by OL, benzenol also. But we know the common name phenol for that. Benzenol nothing but what? Phenol. These all three names are correct. Among these three you can use any one of the name. Okay. Similarly for amine usage. In the place of alcohol, I will take amine. In the place of Cl, I will take Br. Okay. Similarly, students, here the preference is given to amine rather than this halogen group. Okay, then it is at the fourth position. Okay, then become 4 bromo. This one is called as benzene amine version. Benzene ring, but last N is replaced by amine. This is also benzene. Next, so this is at which position? Or you may consider this one as aniline. Benzene ring with NH2 group is aniline. So this is 4 bromo aniline. This is also correct. Okay. Next, if you want to consider, this is ortho, meta, para. That means para, just you represent in P, para, bromo, aniline. Or you may take it as para, bromo, benzene, amine. All these answers are correct. Understand? You may write it as para, bromo, benzene, amine. So what I told students, there is no exact proper way for naming of these compounds. Of course, based on the priority, they have two names. By the derivatives of benzene, they named as benzenol, benzenol, benzoic acid, and also benzenamine, like that. But literally, the commercially they called as aniline, phenol, carboxylic acid, phthalic acid, like that. Understand? So this is another. So another one example I'll give here, same time. This one is CH3 and this one is iodine. Okay. So instead of that, no need to write ER only, you may take it ER also. I am not telling you to take only at the iodine position. Only at para position. Students, I will take this. Instead of, okay, CH3 is here. Let's take this one. Later I will take another one example. Okay. So what it follows? Benzene is there, CH3 group is there, iodine is there. Okay. So if you consider this is 1, 2, 3, 4th position. The name follows what? 4 iodo methyl benzene. Because I comes first, 4 iodo methyl benzene. Correct? Or this is at the para position means this is para iodo methyl benzene, you may write. Okay? And remember one thing, in this benzene ring substituted with CH3 is called as toluene. Okay, if the common name of this benzene ring with CH3 is toluene, this one is also named as 4-iodotoluene and para-iodotoluene. Okay, students. So this type of nomenclature where they will give. So in the examination, you can write this, and this. They'll give full marks. If they ask any nomenclature of this compound, for a 1 marks, if you write any one of the name among these 4, you will get full marks. But in the NEET examination, they'll specify. They will give all these names along with the other names, like 4-iodomethyl benzene, para-iodomethyl benzene, 4-iodotoluene, and 4-methyl iodobenzene. So this one is wrong. 4-methyl iodobenzene is wrong. The preference is given to this rather than this. Understand? Like that. They may ask all these correct options. Any one is wrong. So you have to choose wrong among them. This type of different names they are going to use in the NEET examination. Understand? And the last one, the example is for NO2. That is nitrobenzene. Here it is Cl. Okay. So for nitrobenzene, no name is there, students. This is 1, 2, 3 means you may write it as 3-chloro nitrobenzene. 3-chloronitrobenzene. R, with respect to this is which position? This is alkenes, this one is meta. So that is meta chloro nitrobenzene. Means this meta and chloro are, sorry, nitro and chloro are meta position to each other. Next, if two or more compounds are, and go to here it is Br, you assume here also Br, you assume here also Br. Instead of OH and NO2 you take OH. What is the name follows? Listen, this is 1, 2, 3, 4, this one is 5. 1, 2, 3, 4, 5, this one is 6. Okay, then this is 2, 4, 6 tribromo-phenol. If more than one halogen atom is there, 2, 4, 6 trinitrophenol. So tribromo-phenol. That is with respect to what? Position. Okay, so this is all about the nomenclature of the organic compound. As I told you, you may consider it as a benzene with the functional groups, or you can take it as a common name like phenol, anilene, toluene. Okay, that depends. So this is all about the nomenclature. Next one is the preparation of haloalkanes and haloarenes. In that, students, still first I will discuss about the preparation of haloalkanes only. Later I will discuss preparation, physical properties and chemical properties of haloarenes. First I will discuss the physical properties, preparation and chemical properties of haloalkanes. Understand? Later haloarenes. Listen, first I will explain how the preparation will take place. Preparation of haloalkanes. Haloalkanes only, not arenes. Only aliphatic compounds. In that, 3 steps are there. First one, from alcohols. Second, from hydrocarbons. Are you saying hydrocarbons? Third, from halogen exchange reaction. Halogen exchange reaction. Okay, these are the main students. In that, again types are there. These alcohols from reaction with HX type compounds, that is halogen acids. Okay, second, reaction with phosphorus pentachloride and phosphorus trichloride, PCl5 and PCl3. And last, reaction with thionyl chloride. Okay, so students, in these two, only chloroalkanes will form. Purely chloroalkanes. Okay, here if we use instead of Br, we will get bromoalkanes. Instead of that, we use Phi, we will get iodine. But these two are purely used for what? Chloroalkanes preparation. Understand? These 3 methods: reaction with HX, reaction with PCl5 and PCl3, reaction with SOCl. So in hydrocarbons, from alkane is there and from alkene. From alkane it is substitution reaction. From alkane it is substitution. From alkene it is addition. According to Markovnikov rule. According to Markovnikov rule. Addition according to Markovnikov. Okay. Next, from halogen exchange means two types of reaction is there. One is Finkelstein, another one is Schwarz, which are very important for 2 marks. The name of reactions, whatever I am going to say in this organic chemistry, those are very important for 2 marks. Okay, so these are the reactions. Reaction with HIX, PCl5, SOCl2, alkane and alkene from hydrocarbons, from Finkelstein and Schwarz reaction in halogen exchange method. These are the preparation methods. Okay, if you know these things, students, alcohols means what? Which type of compounds? Yes, alcohols means it consists of OH compound. First one. If it reacts with HX, what we want? Haloalkane we want. Haloalkane means RX compound. If R is there, Fe is there, they reacted together means remaining is H2O. This is the way to write the reaction. Okay. Next, consider this. R is there, OH is there. Okay. If we react it with what? PCl5. Okay. What we want? RX we want. Sorry, RCl we got. Remaining is Cl4P. Then it is HCl will remove. As it is H is there, Cl is there. Remaining is POCl3. This is the reaction. Remaining is P here, O here, remaining is Cl3. So third one, in that A, in that B. ROH is there and this PCl3 is there. Okay? Here there is no oxygen atoms here. So assume students here 3 moles of ROH. And you will get 3 RCl plus H3PO4. So H3PO3, phosphoric acid. Okay, next SOCl2, third one. ROH we want, SOCl2 is there. One is we want RCl. Remaining will go HCl. What will remain? One SO and O, that is SO2. This is the reaction, simple reaction. I am writing only general reaction. I am not explaining already preparation. In the next class, detailedly I will explain one by one. Okay? Just I am giving hint to you people. So if you make a notes like this, you can easily write the answer. So students, instead of the alcohol, if they gave ethanol, you have to remember, you have to know how to write the name of ethanol. Ethanol means what? This R group is ethane, C2H5OH. Then this R is replaced when ethanol reacts with HCl. That means instead of ROH, you have to take C2H5OH. In place of HX, you have to take HCl. Then you get C2H5Cl, ethyl chloride and water molecule. This is the general reaction. But in the examination, they won't ask general reaction. They directly ask what is the product formed when ethanol reacts with hydrochloric acid, hydrobromic acid, hydroiodic acid. What happens when propanol reacts with phosphorus pentachloride? What are the byproducts? They may ask. Okay, if the methanol reacts with sulfonyl thiochloride, okay, sulfonyl or thiochloride, then what is the byproduct? They'll ask like that. They won't ask write a reaction for preparation of alkanes from alcohols. They don't ask like that. They never ask. They particularly ask with example. Understand? So next, this one is alkane. So listen, alkane means I'll take example of methane. So if here Cl2 ions, in presence of salicylate, it forms CH3Cl plus HCl. So instead of that, if I take This one. CH2, double bond CH2. To this HCl is added. So one will get with the CH3, one will get with the Cl. So instead of that, if I take CH3, CH double bond CH2, if it is treated with HCl student, Cl is attached here, H is attached here. You know that is what I call as Marconi-Karp rule. Addition takes place according to Marconi-Karp rule in the unsymmetrical alkanes. Okay, I'll explain in the next class. So this will get CH3, CHCl, CH3. Next one is halogen exchange reaction. Means first one RX compound is there. If it is reacts with NaI in presence of ether or acetone. Okay, halogen exchange means this is exchanged with this. Then the product is Ri plus NaX. If you write this much, you will get 2 marks. Okay, second one, for Schwarz reaction. Instead of this, we will take AgF. Again, halogen exchange takes place means it forms AgX plus Rf. Okay, so this is the preparation of haloalkanes. This is what I am going to explain details in the next class. Okay, you remember this thing, you keep on practicing that. You just be ready with the R group. I'll say which type of R group you have to substitute by telling the name, like ethanol I will say, methanol I will say, 2-methyl butanol I will say, tertiary butanol I will say. So that type of alcohol you have to ready to write. Okay, name of the alcohols followed by the reactions. Understand? So you be ready with this in the next class.